In this video, we're going to go over solution dilutions. A solution of lower concentration can be prepared from a more concentrated solution, also known as a stock solution, by dilution. The equation shown below is the dilution equation. The more concentrated solution is indicated on the left by the 1. So concentration of the first solution times the volume of the first solution is equal to the concentration of the second solution times the volume of the second solution. The second solution is the diluted solution, or the less concentrated solution. So C1 is going to be greater than C2. Volume and concentration are related by inverse proportion. So if you increase the concentration, you decrease volume, or if you increase volume, you decrease concentration. If you using concentration units of molarity, the equation changes from M1V1 to M2V. So M1V1 equals M2V2. So instead of C1V1 equals C2V2, the C is turned into M because the units of molarity are a capital M. So to practice, to prepare 100 milliliters of a 1% aqueous mass volume saline solution from a 10% aqueous mass volume saline solution, what volume of the stock solution should you add to the 100 milliliter volumetric flask? So go ahead and pause the video, and then when you're done, turn it back on and we'll do it together. So our equation is C1V1, C2V2. Our initial concentration is 1%. Our volume is 100, or we want to know what volume. We want to know what volume of the stock solution, so this is our initial concentration, or C1, should you add to a 100 milliliter flask. So we want to make, this is 10. So we have what volume of the stock solution, which is 10%, do we need to make a 1% solution, 100 milliliters of a 1% solution. So we want to prepare, our final is 100 milliliters, so this is V2, of a 1% aqueous solution, this is C2, from a 10% aqueous saline solution, so that was C1. We are going to divide by 10, and the volume is equal to 10 milliliters. Make sure that your units are the same, so whichever unit your V2 is in, your volume, your V1 is going to be in that volume, and then make sure your concentration units are the same as well. I kept my concentration units in percents, and I didn't change them to anything, so I can just keep them as a 10 and a 1. For practice, what is the molar concentration of a lidocaine solution prepared by diluting 10 milliliters of a 2 molar lidocaine stock solution to the mark in a 25 milliliter volumetric flask? So in this case, we're going to use the equation M1V1 plus M2V2. Go ahead and pause the video and work on the solution, and then come back and we'll work on it together. So for this example, we want to know what is the molar concentration, the final molar concentration prepared by diluting 10 milliliters of a 2 molar solution and 10 milliliters of it. We want to know the final molarity, and our total final volume is 25 milliliters. So we have 10 milliliters of a 2 molar solution, and we want to know if we have our total final volume solution of 25, so we dilute that solution to 25 milliliters, what is our final volume or molarity going to be? We're going to divide each side by 25, and our new molarity is 0.80 molar. And this number makes sense because the new concentration is less than the initial concentration because we did a dilution, and dilutions are less concentrated solutions. So solutions can be prepared from more concentrated solutions, a process known as dilution. The dilution equation C1 times V1 equals C2 times V2 can be solved for any variable provided the other three variables are given.